Hi, I'm Ashley Phillips, Project Director with Sierra Watershed Education Partnerships, or SWEP, and today's video is a how-to video for collecting water quality monitoring data on our local creeks. The data that you collect and the videos that you're going to be creating are going to be part of a larger education and outreach project that SWEP is collaborating with the Truckee River Watershed Council on. And the goal is to create student and community awareness of our watershed, what a watershed is, how it functions, and what some of the pollution sources and threats to the watershed are. So with this particular project, the Truckee River Tributaries Sediment Reduction Project, we are looking at how the tributaries, the creeks that feed into the Truckee River, are doing, what their water quality is, and we're also concerned about the amount of sediment that's being transported by these creeks into the Truckee River. So that's part of the awareness that we are going to be sharing with our community as well. So before getting started on any water quality monitoring or data collection, I want you to be safety conscious. So safety first. When you get to your site, so sort of look up and down the stream, assess it for safety, be aware that the water's moving quickly, it's cold, and the edges of stream banks are slippery. So just watch your step and be cautious of any hazards.
Step 1, fill out the top of the data sheet. So you want to make sure you get important elements like the site description. What part of the creek are you on? Is that a wide open gravelly section, or is it the side of an eroding bank, or is it really a narrow part with rapid water movement? Also, you want to make sure you get the current weather conditions, because that can also affect what you find in the creek. If it's been raining a lot recently, you're going to have a lot more runoff, and that might stir up the water. So make sure that you write that down, and any recent weather trends are really helpful.
So after you've filled out the top part of your data sheet, that sort of where you are, when you were there, and who you are, then you're going to start collecting the data. And we're going to be looking at qualitative and quantitative data. So quantitative data is the numbers data, and that's the data that you're going to be using tools to capture that data with. So the first tool we're going to use is a thermometer, and we're going to collect air temperature as well as the water temperature of our creek. So first you're going to want to orient yourself to your thermometer. You want to check and see, is it a Celsius or Fahrenheit? So make sure you look for evidence to see which one it is. This one is reading to me in Celsius. And then orient yourself to the scale. Make sure you understand how the scale on your thermometer works. You're going to take the air temperature in the shade. So find a tree, leave your thermometer there for a minute or two, and then record your air temperature. So the air temperature in our location is 22 degrees Celsius. I'm going to jot that down right here. Make sure you put the scale in there so I know which temperature you are. Okay, to collect the water temperature, you're just going to put the probe of your thermometer, that bottom part, in the water and leave it there. You're going to be wanting to look for the level of the fluid inside the thermometer, wait till it stops moving, and then gather that temperature data. So for me, our water temperature is reading at 11 degrees Celsius. So 11 degrees Celsius is in that cold range between 5 and 13 degrees Celsius. And that's the ideal temperature range for our native fish. So we would say that that's a good water quality indicator. So the next thing we're going to measure is the dissolved oxygen, the amount of oxygen in our creek. And we're going to be using a dissolved oxygen test kit to collect this data. There's a small sample cup inside of your test kit, as well as an ampule. So you're going to leave your ampule with your test kit, take your sample cup down to the creek, scoop up some water, and you can bring it back to your test kit. And this is the fun part. What you need to do is break off the tip of the ampule into your sample cup. And the way you do that is by carefully pushing your thumbs together, down and sideways on the cup. So you hear that snap. And then that breaks the tip off. The water from the creek gets sucked up into the ampule. And you can have it mix by going up and down. and you'll see it changes to a shade of blue. And once it stops changing color, you're gonna move your whole test kit to the shade so you can get a reading. Okay, so once you're moved to the shade, you're gonna measure the ampule that you collected against the scale here. And the scale goes from 1 to 12. The lighter shades of blue mean less oxygen, and the darker shades of blue mean higher rate of oxygen. And you're gonna just kind of put your ampule in alongside the scale to see which shade of blue you think it best matches. And I'm gonna say for me, it seems like it's pretty close to an 8. So I'm gonna record 8 parts per million on my data sheet. Once you're done recording your data, you need to dispose of your tools safely. So the broken ampule, be careful, it is broken glass. You're gonna need to put that in a little trash baggie to take out with you. And then your sample cup has a piece of broken glass inside of it. So I'm gonna be careful. When I dump it out, I strain it through my fingers and try to tap out that broken glass and dispose of that with my broken ampule as well. Okay, so dissolved oxygen is a measurement of how much oxygen is in the water of the creek. Higher amounts of oxygen is obviously better for the wildlife and animals that live inside of the creek. So having that darker blue color is an indicator that we have a greater amount of oxygen and therefore a healthier creek. It changes along the creek how much oxygen is in. So in places where the water is moving, where you see that white water, that's an area where there's going to be a higher level of oxygen, and that's because the air from the sky is being mixed into the water along those white water riffles. There are other places along the creek where you might find lower oxygen levels, and that would be where the water's not moving and is in a more like stagnant place. So you'll find different amounts of dissolved oxygen on different parts of the creek, depending on how the water's moving. And you can also find different amounts of dissolved oxygen throughout the day. So it turns out that colder water can hold more oxygen. So in the morning when the air temperature is colder, the water is colder. And when we do oxygen tests at that point in the day, we usually find that there's a greater amount of oxygen. And then in the middle of the day, when the air is warmer, the water temperature might be a little bit warmer. It's not as able to hold as much oxygen. And so we see a decrease in oxygen in the middle of the day, which you can start thinking about wildlife and fish in particular and when they're more active. And there may be a correlation to the amount of oxygen at different times of the day that help them to be more active at different times. Okay, so our next test is going to be the turbidity test. And turbidity is essentially the clarity of the water. There's a lot of different ways to measure turbidity. We're gonna be using the more simplified turbidity tube to help us understand the clarity of the creek water. So the way that it works is you're gonna fill the turbidity tube to the very top. And then, once you have it filled to the top, then you're gonna look in over the top of the tube. And at the very bottom of the tube, there is a Secchi disc or a black and white checked plate at the bottom. And so I'm gonna look down. If I can see the black and white checked plate, then I'm gonna say that the water's pretty clear and I have greater than 60 centimeters of clarity in this creek. So I'm gonna just note down on my data sheet, greater than 60 centimeters. If this water was murky and I couldn't see the Secchi disc, then what I would do is I use this little tube to release the water while watching. And then at the point where I can see the tube, I stop and I look on the scale, and let's say that's the point where I could see the Secchi disc, I would record 50.3 centimeters on my data sheet for the clarity. So for our turbidity test, our water comes back with a pretty clear rating, which is good. A more sophisticated turbidity test would probably show a higher particulate matter than we are able to identify with this turbidity tube. But this is just one way of collecting turbidity data. So next we're going to be measuring the pH, or the acidity of the creek. So the way we're going to do that is using these handy dandy pH strips. I'm going to pull out one pH strip, and you can see, that they have these 4 different little color squares, and those will change color when they react with the creek water. So you're going to take the pH strip and just swirl it in the water for a few seconds. It reacts pretty quickly. And then you're going to take the strip and match it to the scale on the box. The pH scale wraps around the box. It starts here, 0 to 7, and then if you flip it over, it continues 8 to 14. You're going to line your colors up on the scale to find the best match for all 4. And so for here, I think it's between a 6 and a 7. So I'm going to say, because this green is a little bit lighter, I'm going to say it's a 6. So the pH scale, as you probably already know, goes from 0 to 14. The low end of the scale are the acids. So battery acid, lemon juice, Coca-Cola are all considered acidic, and fish and wildlife can't live in that acidic water. On the other end of the scale, we have basic, so things like bleach and lye and ammonia. Again, all fish would die in this range because the water's too basic. So we want everything to fall right in the middle of the scale. 7 is considered a neutral, and the optimal range for most life on Earth is between a 7 and an 8. So our drinking water, our blood, the ocean, all fall in that neutral range, and we hope to find that in the creek. Oftentimes our local creeks we find measure a little bit on the acidic side of the scale. And while that might have us concerned, we have a natural source of acid in our environment. It's actually from all the pine trees that surround our creeks. Those pine needles contain a citric acid, which is a natural source of acid that gets into our creek. So because it's a natural source, we're not concerned about it. But if we had lower numbers or an unnatural source of acid, that's when we might be concerned about our water quality. So the last bit of data that you're going to collect for water quality monitoring is the qualitative data. So you're not going to be using any tools except for your own built-in observational skills. So the first question is water appearance. So you're going to just look at the water and describe it. Is it clear? Do you find evidence of scum, foam, oil, or anything else? Here at Bear Creek, I would say our water is clear, so I'll note that. The next question is the stream bed coating. So I'm going to look at the stream bed, the bottom of the creek, and I'm going to look for evidence of any kind of coating. In this case, I'm going to say while it appears, to be a orangish brown, there's no actual coating. That's just the color of the rocks. So I'm going to say that there's none. And the final test is the smell test. You're going to look to see, or not necessarily look, but smell to see if the water has any odor. So you get to just scoop up some water, stick your nose in, and in this case I would say it has no odor. We're also asking that students create 2 short video clips. One is sort of a water quality monitoring report video clip, and the other is just why watersheds are important video clip. So you're going to introduce yourself, tell people where you are and what you noticed as a result of the data that you collected. So here's my example of how I might shoot that. I'm Ashley. I'm a student at Sierra Watershed Education Partnerships, or SWEP, and today I was doing water quality monitoring along Bear Creek. The results of my data collection show me that this is a healthy creek. The water is cold, it's clear, and there's plenty of oxygen here. Although I am a little concerned about some of the eroded banks along the creek and what that might mean for sediment pollution in Bear Creek. I love watersheds because they make it so that we have healthy water to drink and to play in. So before leaving the creek, please make sure that you do an inventory check. Make sure all of your equipment is collected back into your bag before leaving the creek. So you want to make sure you have your thermometer, your pH strips, your dissolved oxygen kit, as well as the turbidity tube and the data sheets. Everything's collected. You've left no trace, and then you can bring all that stuff back to me.